Thank you for this presentation. So we now continue with another important topic, which is digital automatic couplers. So the delivery.
Yes.
So
Hello.
Christoph Klose, are you here? Yes?
I'm here. I hope you can hear me well.
Yes, very well. Thank you. The floor is yours.
Okay, thank you very much. So thanks a lot giving me the chance to introduce to you today the digital automatic coupler. The topic has mentioned already in the morning a couple of times. It's very important, I think, for the future of rail freight. A few words to myself. Christoph Klose, I'm working for Siemens Mobility in Germany. I'm heading there the yard solutions business, so mainly for freight. I have a background mainly in rail automation, and on top of my responsibilities in Siemens, I'm also leading in EDP, the DAC Delivery Programme, the Work Package 1. Maybe let's go to the next slide, please. So, and what is it all about? And it's, let's say, coming from manual to automatic processes. And you see here as an example, the coupling, and the whole project goes around coupling, but what you will see in the next slides and here in the next minute, that what we're talking about is going far beyond automatic coupling and uncoupling. It's really about automating and digitalizing the processes for building freight trains. Maybe let's go to the next slide. What you could see here a little bit is the areas where we are challenging, because what we really have to make sure is that the rail freight and the infrastructure getting from a bottleneck will lead to a backbone, because the potential to save emission in transport is immense in rail. But to make this really happen, we have to increase the productivity and the quality. And as a symbol for productivity, we have to go from manual processes towards automated processes. And on the quality side, we have to go from paper to digital. And maybe we can come to the next slide where I go a little bit more into details. So what we really have to make sure is that we really have to use our capacity in a better way. So we have to make more use of the existing infrastructure with faster trains, with more punctual trains to also reduce the disturbance. Important is also to increase the productivities. As I already said, we have a lot of manual processes here around handling of freight trains, so the productivity has to be increased. We have a chance to increase speed and also the efficiency of the assets. Quality is a topic, because freight trains are currently very well known for not being on time or being unreliable, and this has to be increased. We really have to make sure that we can handle disturbances in a much better way, in a much more automated way, and inform the customers much better. And this is also something where the digital automatic coupling should contribute significantly. But when we're going a little bit to some other aspects, it's also the worker safety, because the manual processes in rail freight are sometimes, let's say, taking place in a different environment, in a dangerous environment. They're taking place during day and night, all weather conditions. So it will also help here with automation to improve the situations also in terms of safety. On the economics, it's a huge program. You will see later on that this is really something what's touching the whole sector of rail freight in Europe. It will create a large opportunity for technology, but also for creating new employment opportunities in Europe, not necessarily only on the supplier side, but also on the operator side, because if new services can be offered, This will also make the business, and this is the aim of the operators, a much better one. And last but not least, rail is highly contributing to the Green Deal. Each ton of freight, what can be transferred or can be shifted from road to rail, contributes to the CO2 reduction, because the rail is much more environmental friendly compared to the road. Therefore, there's a huge need to make all this happen. Can we go to the next slide, please? So what you could see here are the use cases, because I mentioned before, when we're talking about the digital automatic coupler, we're not necessarily only talking about the coupling and uncoupling processes. We're talking about some other processes, like automatic brake testing, like building heavier and longer trains, to have train integrity, to make it feasible also in the future to introduce ETCS level 3 also with freight train, to introduce EP brake to improve the braking performance, but also then lead to increased speeds, monitoring the condition of the wagons and of the goods for the customers, to apply automatic parking brake to even further automate the processes and make the things much more efficient. I mentioned also the automatic uncoupling. We would also then not only couple automatically, we would also uncouple automatically. That means here in this case we're not uncoupling. We would like to support with the digital automatic coupler also the wagon inspection, also one of the processes, pretty time consuming, but this will go together with maybe video gates and checkpoints in the infrastructure. And last but not least, we would also supporting with the digital automatic coupler longer trains, distributed power concepts, together with the IP brake, to really help that the rail transport will get more efficient. Maybe let's go to the next page. And on the next page, I would like to also give you some idea what is the time frame we're currently talking about. Because what you can imagine, if we introduce a new coupler in Europe, this is something what has to be done also with a sound migration strategy. And currently in Shift to Rail, in the EDDP, European DAC Delivery Programme, we're currently working on migration scenarios. And we are currently, and this, please take this as an indication, we are currently working this out also in the context of the Europe's rail. How to integrate and how to, let's say, migrate the existing rail operation, freight rail operation towards a rail operation, freight rail operation based on the digital automatic coupler. And you see here the second half of this decade will be pretty decisive. So the first half of this decade will be mainly for the standardization and the development, and the second half of this decade will be then the implementation and the migration of the whole system towards this. We are evaluating scenarios currently, one very short scenario with a preparation time, but maybe we also come to a little bit longer scenario. But for both, it's very clear we have to do the conversion towards the DAC until the end of the decade, because the process during the migration is pretty challenging also for the operator. Therefore, we have to make it as short as possible. Maybe let's go to the next slide. Because if we're talking about the DAC and introducing a new coupling system, we have to understand that we have approximately 500,000 freight wagons and approximately 17,000 locomotives in the network of the UIC. And all of them, not all of them, but 90% of them have to be converted towards the digital automatic coupler, because the wagons in Europe are pretty freely exchanged, especially the ones of the core fleet. And what really is a challenge here, that these wagons and locomotives are owned by different rail operator, And we have to make sure that the migration towards this new coupling takes place in a pretty short time and is highly coordinated because all the different stakeholders had to be synchronized very well. The equipment will be manufactured later on by different manufacturers, and here now standardization kicks in because you can imagine this has to be fully interoperable, and therefore intense work in specification and standardization is required. Sen already started the work on the standard on the mechanical part. Senelec TC9X also started a couple of weeks ago. And on top of that, also the TSI documents, the adaptation of the TSI documents are also kicked off. So standardization of the equipment will play a key role here. Maybe let's go to the next slide to explain you a little bit what are the elements of the standardization and specification. So one element for sure is the coupler itself. You see here the two pictures as a sample. The coupler of the wagon, the coupler of the locomotive. But we're always talking about a digital automatic coupler, and digital automatic coupler means, sorry, can you stay on the slide for a second, please? Thank you. We would also introduce an energy system. That means we would like to run a cable through the whole train to provide energy to all wagons. But if we would like to run such a cable through the train, we also need an electrical coupler, and you can imagine such an electrical coupler have to be standardized, that the wagons from different operators and different manufacturers are fitting to each other. And last but not least, we will also establish a communication system through the train to make sure that the locomotive can communicate with the wagons to enable the use cases you have seen before. Now we can go to the next slide, please. And here you see maybe the picture is a little bit busy, but only would like to explain to you a little bit what is the complexity we're currently talking about. So we have, and here we're talking about the energy system. We will have equipment on the locomotive, what is supplying the power to the train. Sometimes people think, oh, especially electric locomotives, power is available, but we need, let's say, not the power is currently available of the locomotive. We have to make sure that the power is on the right level. Feed it to the train. You could see here it will be a cable system, cable-based system, providing the energy to all the wagons. And then on the wagon as such, we will have a power management system supported by an energy storage to make sure that the applications are also working if the locomotive is not providing energy, because the wagons are also parked for quite some time and therefore they have to work. But what we also said, it's important that we also standardize not only the interface between, for instance, the locomotive and the wagon, but we would also standardize the interface to the applications on the wagon as such, because we would like to make sure that also on the wagon you have interoperability, so that you can also later on can apply additional applications maybe not available today to the system. So therefore our focus of standardization is not only the interfaces 1 and 2, where we are communicating or transmitting and aligning between the locomotive and the wagon. We would also make sure that on the wagon we have a standardized interface to the consumers and to the applications. Let's go to the next slide. Here I would like to introduce to you a little bit the communication architecture. I mentioned we would also provide communication, and if you today think about communication, there are general two aspects of communication here in the DAC. One aspect is the communication in the train, especially the use cases you've seen before. They needing a communication within the train, and this is something what we would like to have shown here with this, what we call it interface A, where the wagon are communicating with the locomotive. Locomotive the master, wagon will be the slave. But this communication and this interface is pretty challenging because what we have to really make sure here is that we have to find something what is really robust, because we are coupling under all conditions over coupler, coupled not in workshops, they are coupling in shunting yards. So we have to find a communication system what is really robust enough to be reliable also under these kind of conditions. We will see this in a minute. We are looking into various different standards, and we have to find the right communication physical channel here. But it's not the only interface we're currently looking at. I also mentioned that we would like to look into have a standardized communication on the wagon as well. Here is a little bit easier because here we're talking about, and this is what we see here, the interface B, where we say, okay, this is our short-range communication. Ethernet would be here maybe a potential standard, but you can also consider other standards. But we would like to provide also a standard here on that level to make the system interoperable and also extendable in the future. But I would also mention one other aspect, that a lot of data will be generated on the wagon and on the locomotive. And these data are not necessarily only be used for the operation of the train, also on the wayside by various stakeholders, starting by the railway undertaking, by the wagon keeper, infrastructure manager, but also customers would like to need the data. So therefore we say, okay, these kind of information have to be transmitted directly from the individual wagon towards via mobile communication, like the telematics system of today doing it, directly to the operator or to the supplier, and then distributed there to the other stakeholders. We are not using the locomotive as a data concentrator, so this kind of concept we would also like to introduce with the DAC. Okay, let's go to the next slide. Here you see the classical communication pyramid, and what we are currently focusing and what we are currently investigating is the physical layer, the lower to lower layers to find, and we are currently testing in the project DAC for EU, funded by the German Ministry of Transportation, various physical layer to find out what is the most robust physical layer for such an application. And then what is our aim is to apply on the higher level already existing standards like ETB, or what's also currently going on in Connector 2 to find there potentially existing technologies, but also existing standard to be applicable here. Also on the physical layer, we are not necessarily looking to develop something new. We're also looking into standardized communication system, but they have to be robust enough to sustain and reliably in the environment. Maybe then let's go to the next slide. I mentioned before that all of this is only helpful, the energy and communication system, if we have put the application on top. And these also require standardization, because if you would like to apply, for instance, an automatic brake test, the equipment of the different wagons have to also support the same process and have to work in the same way. So standardization will also be a topic not only on the energy and communication system, it will be also a topic one level higher on the applications. So, and in EDDP, we will start soon also to tackle the standardization of these packages in the context of the Europe's Rail Joint Undertaking. So maybe let me come to an end to my summary slide. Thank you very much. It's very important because the DAC is a key enabler to really and to make sure that more freight can be converted to rail to achieve the 30 by 30 target. And this can only be achieved by increasing the flexibility, because we have to reduce the transport time to improve the reliability, and flexibility is also a very important topic. As said, the DAC is one of the central elements to optimize the current processes. And we have to do everything to ensure the rollout of the DAC in the second half of this decade. And this really requires all stakeholders to work together. And my last sentence I would summarize with: failure is not an option. We are not the first attempt to introduce an automatic coupler in the freight rail environment. But this time, really, we have to make it happen. We have to do everything that it works, because if you see what's going on the road, that by the end of the decade, we might see self-driving, electrified trucks on the roads, and if then the rail and the freight rail is still driven by a lot of manual processes, then it will be very difficult to convert even more share and more freight to rail. Then therefore we have to be successful there, and we need the help of the whole sector to make it happen. Thank you very much for giving me the chance to introduce this very important initiative to you. Thanks a lot.